Hi everyone and welcome back. Last time we assembled the AOpen i855 and the Pentium M. Today we're gonna look at the benchmarks for the stock settings. And we will start with the BIOS. The standard features are pretty common. And also the advanced ones. The advanced chipset features allows you to specify the timings on the RAM, but the interval for the values is not as wide as I'd hoped for. The AGP aperture size is specifically important as I had failures to start 3D Mark 2001 with a setting of 64 MB. The rest of the pages are pretty standard. Once we reach the frequency control, we can set the frontside bus and we can also modify the CPU voltage settings, which unfortunately can only be adjusted for lower values than the recommended value for the CPU. So the overclocking options for this board are pretty limited, and we are also lacking a fixed AGP frequency that will make the overclocking a bit harder. It looks like I won't be able to explore the full potential of this CPU. One last option we will explore in this BIOS is the credits. Let's look now at the CD contents. We are not usually doing this, but since this board and setup is kind of rare, we are going to explore a bit more than the usual. Now let's go to Windows and see the details about the configuration. This CPU was available starting with 2005 and we are pretty far from our 2003 starting point. But this is a notebook CPU, so I guess a 2-year difference is acceptable for a notebook CPU to catch up to a desktop CPU. This CPU is built on 90nm technology and it has SSE2 instructions, making it similar to the Pentium 4 540 we had on the ASRock 4-core Dual. But don't be fooled, the similarities end here. Out of the all CPUs we've tested so far, this has the lowest frontside bus, and we will see how that affects the performance. Every other CPU motherboard we had in this series has a 200 frontside bus, but it compensates with a 2 MB of level 2 cache, doubling the cache we had for the Athlon 64. You can see that we also have a 3:4 ratio between CPU and memory, just to have a little more bandwidth. Now let's start with the benchmarks, and we start with SuperPi that produces an impressive time, and we continue with PCMark. Now we will look at Sandra 2004. Then Cinebench 2003, this is CPU Bench 2003, Finally, we look at memcache, then at the encoding speed, and we close this batch with ViewSpec Performance 7.1. Next, we move to graphics benchmarks, and we will add one more test today. We usually start with 3DMark 2001, but today we are going to try 3 other drivers besides the regular 6693. Starting with Aquamark 3, we get back to the usual 6693 driver. Code Creatures is next, and we follow it with X2 the fret. The last two graphic tests that we are going to look in detail are Comanche 4 and Unreal Tournament 2003. Since the next few tests are quite repetitive, I'm only going to show the results, not showing the run anymore. And we will start with Quake-free Arena demos without GL extensions, and follow it with the tests with GL extensions enabled. We will continue with two other Quake-free engine games, Return to Castle Wolfenstein and Jedi Outcast. Serious Sam and Far Cry are next, both 3D and OpenGL renderers. Although I've run the test, I can't find the result for OpenGL in Far Cry. Next, there are some more OpenGL tests. And finally, Fable, Realstorm, and Chameleon benchmarks. To add to the benchmarks, only for this motherboard, we will look at Gunmetal. But the performance and frame rate were so bad that I decided to speed the benchmark by a factor of 3. Next, we're going to look at two games. Since my capturing card introduces a delay of about 0.1 second, I decided to use a Y-VGA splitter and play the game on a monitor. Unfortunately, I didn't check the capture and everything was darker. Fortunately, the editing software is helpful and I'm able to make it visible. Unfortunately, the cable was poor quality and there are a lot of artifacts present. The only good thing about this capture is that I'm able to drive the car now. Next is Red Alert 2 that had the same problem. You can see the original capture in the first few seconds. Since I can't leave this clip with such a bad capture, I'm going to try something a bit different. In the next video in this series, I will make a comparison between latency and bandwidth for the Pentium M. We are also going to introduce the pilot episode for a new series using this motherboard. Let's upgrade this build. I'm not going to comment about the new components, we are only doing this now for the game capture. And we're going to run Mafia in 1920 by 1080 with no frame limiter and see how it goes. A reason why I often pick Mafia for the game demo is that it supports lots of resolutions, and also because of its ability to play as a racing game or a shooter. You can see that going back to the regular capturing method has worsened the driving, but at least we almost get 130 frames per second in 1920 by 1080, which is great. The Pentium M has a very low power consumption, 133 frontside bus, no dual channel, and it's only 2.2 GHz. To add to the list of penalties, there are minimal overclocking options on the motherboard. Despite some of these disadvantages, this was one of the fastest CPUs we had in this series. The next episode is going to look at something more specific related to Pentium M, memory latency versus memory bandwidth, which is better for overclocking and benchmarking results for socket 479. In the last episode, we are going to look at the overclocking potential and the graphs for the benchmark results. Thank you and see you next time.